student, in this video we're going to solve a problem which appeared in the year 2010 JEE main paper. So first we try to understand the problem statement. Here we have a complex number omega which is a cube root of unity, and it says that a fair dice is thrown 3 times and R1, R2, R3 are the numbers, right, obtained on the dice. That means R1, R2, R3 obviously lies between 1 to 6, and we have to find out the probability that omega to the power R1 plus R2 plus R3 in that given form is equal to 0. So let's go ahead and solve this problem. Okay, let's go ahead. So here it's given that omega is a cube root of unity. So therefore we know that omega cube must be equal to 1, and 1 plus omega square will be 0 for anything, right? Let's go ahead now. Now we take any integer, positive integer n. So therefore omega to the power 3n is also equal to 1. Now let's multiply this omega to the power 3n with the relation 1 plus omega squared. So therefore it will be 0. Hence we can obtain that the sum of omega to the power 3n and omega to the power 3n plus 1 and omega to the power 3n plus 2 all are equal to 0. So this sum will be 0. So therefore we may conclude from here that, right, that if our relation are omega to the power r1 plus omega to the power r2 and omega to the power r3 is 0, then this r1, r2, r3 must be chosen in this form, right? That r1 may be 3n, r2 maybe 3n plus 1, and r3 is 3n plus 2. Now also notice that, right, that as summation, right, that we are commutative, so we can interchange their places, right? For example, omega to the power r1, r2, r3, right, and omega to the power r3 plus omega to the power r2 and omega to the power r1, it's actually the same way of selecting the problem. So therefore we can say that this r1, r2, r3 can interchange their values. So therefore, okay, we can consider that condition. Also notice that as r1, r2, r3 are the number obtained while a dice is thrown, so therefore these numbers can be chosen from a set of number only from 1 to 6. So we can have a bound of r1, r2, r3. That's it. Let's go ahead now. See that as r1 is in the form of 3n, so therefore I can take, right, the r1 values are obviously, right, that 3 and 6, so n equal to 1 and n equal to 2. For the next case it will be 3n plus 1, so I can take n is equal to 1, so it's 4, and if I take n equal to 0, it's 1. So r2 equal to 3n plus 1. The previous case I don't consider that r1 n equal to 0, because in that case r1 should be 0, and that will not be possible for when we throw a die. And obviously for r3 it will be 2 and 5. So these are the possibilities r1, r2 and r3 can take. Hence, right, we can say that, right, that r1 can be chosen in two ways. R2 can also be chosen in two ways. R3 can also be chosen in three ways. And hence, right, that r1, r2, r3 together can take in the ways of 2 cross 2 cross 2, which is 8 ways. So there are 8 different ways of selecting r1, r2, r3. But you see that, right, we can interchange the values of r1, r2, r3, right? So therefore, right, they can interchange their values in factorial 3 ways, that is 6 ways. So therefore the total number of ways of selecting r1, r2, r3 will be 8 into 6, that is 48. So therefore there are 48 different ways of selecting r1, r2, r3, such that omega to the power r1 plus omega to the power r2 plus omega to the power r3 is equal to 0. Hence this number 48 will be the total number of favorable event. Now our next job to find out the probability that total number of event. To calculate the total number of event, we should go ahead and see that this case R1, R2, R3 each can be taken, right, in 6 different ways, right, because we are only having 1 to 6. So therefore it will be 6 cross 6 into 6, that is 216. So we get total number of event and total number of favorable event. So hence the probability will of required probability will be 48 and 216 ratio, that is 2 by 9. And hence for this problem option C is the correct answer. That's it. Hope you understood the problem.